received bachelor degree in mechanical engineering from Madurai Kamaraj University in 1989 and master's degree in manufacturing engineering from MIT Anna University in 2004. He has obtained the PhD degree from IIT Madras in 2008 for the research work on smart material actuated compliant parallel mechanism. He is currently serving as a faculty at the Indian Institute of Information Technology, Design and Manufacturing, Kanchipuram, Chennai. That institute is established in 2008. He is having around 13 years of experience in the industry, especially in the area of automation and material handling equipment, and around 17 years in teaching and research experience. He has published around 67 papers in reputed international journals and conferences, including ASME Journal of Mechanical Design, Smart Materials and Structures, and Materials and Design. He is also a visiting professor at the University of Genoa, Italy. He has successfully supervised 4 PhD scholars. His research interests include robotics, smart materials and structures, parallel and compliant mechanism, swarm robotics, advanced and smart manufacturing, ICPS and IoT, and QC control. He is an active member of various professional organizations, including IEEE, ISTE, and SAE. Sree Kumar, sir, is currently an associate professor of mechanical engineering and dean faculty affairs at IITDM, Kanchipuram, Chennai. So, with this introduction, I would like to request our expert, sir, kindly proceed the session.
Yeah, so good afternoon to all of you. Yeah, thanks for the nice introduction. And yeah, this is the first time I am sharing the experience with this Sagar Institute of Science and Technology. I don't know how they got the my name, and so it is the first time. And yeah, thanks for the invitation to the organizer of this event, and also to the participants. And some participants might have already, I think, visited our institution, and because every year I usually conduct this one FDP program of 1 week, and every year our institute also organize various conferences, international conferences. And 2018, one conference like ROSMA, Robotics and Smart Manufacturing, right? International conferences. So that was the first edition. Okay, we organized, and in fact, that the second edition is due in 2020, but it is being missed due to this COVID. And now we're planning for this in 2021 December. But still, I am not sure whether it will happen or not, because we want to. We feel that okay, the physical presence is required. Then only we can say that okay, it is a real conference where we can meet, chat, okay, and eat. So we can meet, chat, and eat. So this is a kind of a pleasure. So through our knowledge and experience, right? And we usually exchange if we physically meet. But even the online also it can happen. But that the pleasure will not. The pleasure of right the exchange of having an exchange of information we may not get. So probably it may right if it is December, if it is not possible, and then we may postpone to next year July. So otherwise it will happen in this December. So you may please watch for any kind of updates. And I think I could see that there are various the senior level also. I think the participants, and the total participants are around I think around it should be around 39. And right, welcome all of you. I think you are from various institutions of our great country, and right. So now government is also giving thrust and right giving thrust for organizing such kind of training programs, and in a technical as well as non-technical patents, right? So that our country will be will get strengthened in terms of product outcomes. Okay, and the designs. Of course, we are excelling in designs and manufacturing. Still, manufacturing there are a lot of lacuna, and but the government is keep on giving a lot of kicks and thrust, so that then India become a self-reliant country in terms of manufacturing, etc. Okay, so with this introduction, I start my session, and so my screen is visible. Could you please respond? My screen is visible, sir.
Yes, sir. It is visible.
Okay. Okay.
Yes, sir.
Thank you so much. And the title of these two sessions, right, and is the challenges of integrating robots and vision systems in IoT-enabled manufacturing systems. We have manufacturing systems, fine, and how to make it IoT-enabled. Okay, that is the current strategy of our entire manufacturing sector. So that, and we can have a number of plans throughout the country and throughout the world, and we will get it united, and we will exchange the information, and even a very macro level information, micro level information, and overall information, the entire set of information and monitoring control, everything can happen through this if we integrate, okay, the A to Z through this IoT part. Okay, so that is the reason now we are thriving hard, and every industry is now thriving hard to and excelling in terms of converting the classical stuff, okay, manufacturing system to IoT enabled system. And right, IoT means it is we are integrating CNC machines, we are integrating robots and vision systems, right? And then with the intervention of humans, without the intervention of humans, all these things are happening now. And today's topic of our presentation is with the challenges of integrating robots and vision system. Okay, and in the IoT domain with application of manufacturing system. So this is our talk of the day. This session. Now I think we can go ahead. The content, I divided the content into three parts. Okay, part one, robots and fundamentals and recent developments. This will be exclusively handled by me. And the part two, challenges in integration of vision and robot system. And part three, challenges in integration of IoT. Okay, these was the part two and part three will be handled by my PhD scholars, because I think they also will get some experience. So we are working together. And so I am dedicating, okay, so these part two and part three sessions to them. And it will be, I think, nice experience, I think, both side, your side as well as. They are very young and, okay, not like me, and very active. And so you can enjoy, really enjoy with these sessions. And the part one, I will give an overall picture, okay, how to integrate, what are the different, what are the issues when we integrate, okay, so with the IoT system and exclusively in manufacturing, etc. So our talk will be focused more on manufacturing and the design aspects. Okay, so now I will move on to this part one. Part one is robotics and fundamentals, okay, and recent developments. What is happening in the robotic development? With exclusively, okay, and focus on the application of manufacturing. So initially, the evolution part is concerned, and right. So the robotics is evolved from very ancient times when and we very directly or indirectly the birds might have not used, but we right, but we keep on deriving a lot of information from nature. So first, the man, right, and started killing animals for their food, and so they used speed as the major criteria. Okay, only speed, because it is bow and arrow, they are basically lightweight, right? Maybe maximum, right? You can say that it is a 5 kg or maximum, what the case. So otherwise, it will be very difficult to handle it. And the later, then mass also people added. So once the evolution comes, the destruction also coming into picture. So the bow and arrow first was used for the killing animals for food. But now the destruction comes, composition comes, then fight and all these things happen. Then they added mass. Okay, the speed and mass also been added. That is nothing but the inertia for destruction. Then later, okay, part, then develop a lot of mechanisms and devices for to extract the truth from the culprits, okay, and to give the mass punishments, etc. Various kinds of. This is only some pictures I have taken from the internet. You can explore further. One can easily explore further. You can get a lot of devices, mechanisms, okay, for used by the used for killing people and used for inducing pain or chopping off the different the parts of the body or capital punishments, to give capital punishments, etc. And all these things have been and copied and taken from the internet. There are various websites and one can explore further, and you will get different kinds of information. And the left side of the figure is the person will be laid over this mechanism, and all the legs and hands will be tied that mechanism. And if the mechanism is actuated or rotated, they dislocate all the joints when the victim is alive. Okay, so that is the left one, and the right one is a coffin torture, or torture, the metal cage. The birds will come and take away your the flesh. Okay, so this is a kind of information, right? Now that is for the dissection of the humanity, and so this is the one which is available in Italy, and lived there for some few years. And this one figure I got, it is donated from UK, it seems, and it is a 12,000 tons press. See, the plus point of this huge structure is that there are many huge pieces they casted as a single piece. For example, see this, they casted as a single piece. Even it is 100 years, I think 120 years old press, and so that time itself, people had the capability to cast the massive structure like this. And these are modern devices, and this is left one. This is a very old. The initial stage of development of sieving machine. It is around 300 years old. The left one. There is a very simple one. After that, it is evolutionized into a modern mechatronic sieving machine. And we have various other mechatronic and devices also. And you see the bottom one is a mechanical press. I think even now also you can find in some few houses in Kerala. And that is used for the extraction of oil basically. And also it will be used as an extruder for the very extrusion of various food items. And this is another kind of evolution in the robotics and the robot humanoids, Asimo, right? And so the bottom are the figures. The another kind of evolution. There is a miniaturization. So it is how to make a very large size humanoid, very micro scale, right? Like an object. So like this, another kind of development also going on. And this is another kind of development, and how to take the information from the nature, and from various devices, various biological devices. That is only few examples only I have cited, and there are many more, and one can easily get the information. And this is another kind of evolution in the robotics, and and we are how to give an intelligence, and how you design a hand that will capable of sensing what is a force, I can apply to handle what kind of object. Okay, so this is another kind of revolution, and that's going on, and how to use how to design a robotic device as a haptic device, so that you can sense, so that you can sense and measure, and when a human hand is come into picture, or human hand is used to move, or human head is attached to move, etc. And this is another kind of developments, the biological devices, and how to imitate, how the motion and even the entire action of a biological available devices, etc. And then we try to copy the same as and the dragonfly and the helicopter. So it is so many things are there. And this is another kind of developments, the spiders and the multi-legged devices. We have various multi-legged devices, and so there is a mechanism area. Those who are working the mechanism, they know it, and so there is a head support, and they are having 6 limbs, and so how to design such kind of devices like spider, cockroach, etc. So that is another kind of evolution. So this is how to design a cockroach. So another slide, and this is how to design a frog, and how to add a jumping, a jumping motion to imitate the jumping motion of the cockroach, etc. And and now we are started using it. It is a recent developments in throughout the world. People started using various mechanisms and devices, or mobile robots, and for agriculture. Okay, so there is another kind of development. And and the recent concept is that how to make a group of robots to work and act in the field or in the agriculture or in the automobile field in a collaborative manner. Okay, so this also is a kind of a development. A lot of research works are going on, and I think those who are working in robots at this area, people might be working with these collaborative robots. And even this is common for even computer science, electronics, and mechanical students or IT, etc. I think before this, I want to know the right. How many of you or any idea from the organizer? It is. I think it seems it is a mix of participants. How many are from electronics domain? How many are from IT domain? And how many are from mechanical domain? Any idea? Any information is available readily? Otherwise, we can go ahead. So I accordingly I can orient right my talk from or is the participants. Can you give an idea? And how many are from? It is like 30, 30, 30, 30, or it is a mix of. If everyone is from electronics and computer science, then I have to reorient. If it is many are from mechanical and and less participants are from electronics, I can orient. I can speak more about mechanical concepts, design, etc. Now you please tell me. At least one of you please confirm.
Sir, around 60 to 70% are from mechanical backgrounds.
Oh, okay. Very good. So then I can then probably then focus more on mechanical aspects. Okay, thank you, sir. And so if you talk about the robot, right, and robots, there are so many things comes under the robots or robotics, and right, there are industrial manipulators, there are mobile robots, and there are application-specific area like underwater robots, robots in medicine, and robots in space, and flying robots, right, micro devices, macro devices. There are various ways in which you can discriminate and the robotic devices. Okay. So then if you talk about the industrial robots, right, and basically industrial manipulators are being used in manufacturing and also logistics. And there are two classifications like serial mechanisms and parallel mechanisms. Now, there are many design aspects are involved, and we should incorporate, right? And without the information of this design, you cannot make a robot to accomplish a particular task. And that is the kinematics, dynamics, and trajectory planning, right? And even forward kinematics, inward kinematics, and then the trajectory manipulator, joint space control, Cartesian space control, right? And there are application specific right designs like palletizing, painting, welding, deburring, and right, and then pick and place operations, etc. If you talk about robot mechanism, right, and there are manipulators and end effectors, and there are sensory systems attached with the mechanism, and there is a power source. And sometimes the power source, if it is a mobile robot, the power source is right. Even the mobile robot also has to carry the power source, right? There are networking systems and navigation and guidance, right? The common communication protocol and there are multi systems or multi system approach, multi agent approach. There are so many things are now it is being evolved, and there are various kinds of control system, right? And there is a linear control system, non-linear control system, and then fuzzy control system, and the genetic algorithm, right? And fuzzy optimized genetic algorithms, so neurofuzzy. There are so many things that okay, every day something is happening as far as robot controls are involved, and there are coding experts, okay, coming from the computer science domain, and still even sometimes in mechanical also, I mean, there are coding experts are there, and right, so. And of course, there is a multi robots means or mobile robot means there are leader for approach, and there are obstacles related, right? Again, stationary obstacle related issues, more that moving obstacle related issues like ditches and like river and with water and with ice, right? With with the incline with the upward inclination, with the downward inclination, and there are so many things and every day, right? And people try to right make a single robot capable of right meeting right or moving in different terrains. Okay, that is the I think right, and many companies are now they're developing various kinds of devices capable of moving in uh, various kinds of terrains. And if you talk about the types of mechanisms, there are serial mechanisms, parallel mechanisms, spatial mechanisms, spherical mechanisms. planar mechanism, redundant, flex, compliant, flexible, etc. What is this? Okay, mechanical students know. Sorry, mechanical participants, you know what is a planar mechanism. A planar mechanism is capable of giving only 3 degree of freedom motions. What do you mean by degree of freedom? Degree of freedom, because when you talk about the robotic, you should know. And right, a planar mechanism is capable of giving only 3 degree of freedom maximum. Correct? And planar, right? Anything that moves on a table, assume that, okay? And you can have an X motion, you can have an Y motion, and you can have a rotary motion with reference to the orthogonal axis Z. Okay? When X motion means X axis and Y axis, and another is can be the rotation with reference to third axis. Okay, that is Z axis. That is a planar. And the spherical, assume that a mechanism are developing that is capable of navigating over the our sphere. Okay, in a spherical space, that will give a spherical space. And then spatial mechanism is what? Spatial. Yeah. If you want to maneuver in a body in space, okay, how many degree of freedom required? You want to move a body in space, okay, air space, right? And how many degree of freedom required? Right, and assume that this is it has to move in space. How many degree of freedom it can have, or how many degree of freedom it is required? Hmm.
6
6
degrees.
degree of freedom, 6 degree of freedom required. The 3x and x, y, and z motion, and the rotation with reference to the 3 axis. Okay, 6 linear motions and 6 rotations. Okay, 6 degree of freedoms are required to maneuver or right to move an object in space. And if it is on a plane, 3 degree of freedom is more than sufficient. Okay, spherical also, but spatial means 6 degree of freedom required. Suppose it is a point. How many degree of freedom a point in space can have? A point. A point in space can have 3 degree of freedom. The 3 linear motions only, because it is a point, right? It is a point. And so rotation will not be applicable for this. A point in space has 3 degree of freedom. A body in space has 6 degree of freedom. Okay, so if you go to define, you go to design accordingly. Because degree of freedom concept is a very basic and fundamental when you start designing any kind of robotic devices. Even it can be a mobile robot also. How many degree of freedom a mobile robot can have? Whether it need to climb up or climb down, or okay. So what kind of, it is a crawling mechanism. How many legs it can have? Each leg how many degree of freedom? Okay, all these things. Okay, degree of freedom comes first when you start to design a particular mechanism or an object. Okay, and then what is a redundant? Redundant means extra. Redundant means extra. And suppose if you want to designing a spatial mechanism, 6 degree of freedom. If you are designing with adding one more degree of freedom, okay, then that degree of freedom is called as a redundant, extra. Okay, and then that our hand, right? Our hand is having how many degree of freedom? Any guess? Excluding fingers. Excluding fingers. Okay, our hand is having how many degree of freedom? Any guess? Our excluding fingers. Okay, how many degree of freedom our hand possesses? Any guess or any idea or any guess? First, before that, our hand is capable of right and moving in objects in space. Hello, our
Holding.
object. See, take this a color, take a calculator. Okay, and I'm holding out my hand. Correct. So it can X motion is possible, and Y motion is possible, and Z motion is possible, right? And Z rotation is possible. Then, X motion, Y motion, and Z motion. X, Y, and Z, 3 linear motions are possible. Okay, now this with reference to Z, okay, I am rotating. Correct? The 4th degree of freedom. Then, then another one. This there is an axis, right? If you can put an axis, now I am rotating this way. Correct? And another axis is here, right? So I am rotate this way. Okay, all the 6 degree of freedom is completed. So our hand is capable of having 6 degree of freedom. Then anything more? Anything more? It is having one more. So our hand is having 7 degree of freedom, excluding fingers. Fingers, okay, another 50 degree of freedoms are there. So that is the reason it is difficult to design a artificial hand having imitating all the degree of freedom. It is really difficult. People are trying, but each and every information, if you want to add, it is really difficult and tricky. So now people are using 3 finger, okay, 3 finger, mostly 3 finger gripper, right, or 2 fingers grippers, right, and more than 3 and all, it is really difficult. Of course, artificial designs are those things going on, but it is a really difficult part to design an artificial hand. So I come back. So our hand is having how many degree of freedom? 7 degree of freedom. And how this 7 degree of freedom is coming? And maybe I think I want to go to the board and okay, sorry, I will. Uh, I go to the. My board is visible. Board is visible.
Yes, sir, visible, sir.
Okay. So now see, I'm drawing our hand. So you got the shoulder. Okay, and okay, so now okay, so it is like a visit and it is like a manipulator now. I'm drawing. And see here is a ball and socket joint, correct? It's a ball and socket joint, right? So it is a X, Y, and it's a 3 axis you can fix. So ball and socket joint, and so you will get only the 3 rotations: theta X, theta Y, and theta Z. Okay, 3 degree of freedom now it is available. Then it is a elbow joint, and you will get one rotation. Okay, here 1 degree of freedom is available. Now you can put, okay, so now you can revolve 1 degree of freedom, okay, and you can move this way 1 degree of freedom, and you can move up and down. So here 3 degree of freedom. So nowadays, okay, 3 plus 1 plus 3, so you have 7 degree of freedom. So the human hand is having 7 degree of freedom, so we have 1 degree of freedom extra. So our manipulator, our hand is a redundant mechanism. So God has given one more, right, degree of freedom. Why? God has given one more degree of freedom, because this 1 degree extra degree of freedom is useful in taking or picking an object with the concept of obstacle avoidance. For example, if you want to draw, right, if you are standing, you are drawing a drawer, right, a table drawer, and right, navigating inside and searching some body, okay, or if you place some body inside a drawer, and if you positioning inside the drawer, then for that 7 degree of freedom is required. Anyone can easily see and right really check, okay, such kind of applications, right, 7th degree of freedom is useful. And so that is the reason God has given 1 degree of freedom, etc., even though 6 degree of freedom is more than sufficient, okay, to maneuver in a object in space. Okay, so we'll go back to the um, flags. Right. Okay. So now degree of freedom. Okay, we will little bit spend more time here, and so this is the serial mechanism, and it is a spherical mechanism, and we have a parallel mechanism, and see our skeleton itself is a hybrid robotic structure. See, we hybrid type. We have right, the leg. Each leg is a serial mechanism. Each hand is a serial mechanism. Okay, and put together. See, our 2 legs are connected. Okay, so with a hip joint, and so our 2 hands are connected with a skeleton. So all together you can say that, right, it is a hybrid mechanism, right? And right, what is a parallel mechanism? If two serial, this to here it is an example of parallel mechanism called as a steward platform. Okay, it is having 6 limbs. Okay, it is like a piston cylinder, pneumatic cylinder or a hydraulic cylinder. It is, or there are motors as well, that is I'm not, we are not going in depth. So it is a like a pneumatic cylinder, okay, and top and bottom there are joints, and like this there are 6 limbs. Okay, it is a basically a 6 degree of freedom mechanism, and also called as a parallel mechanism. So many actions are parallel. Okay, that is the reason It comes under parallel mechanism. So our skeleton comprises of serial mechanism as well as parallel mechanisms. Okay, for example, if two serial mechanisms are connected using a common space or platform, that is known as a parallel mechanism. Okay, we have our skeleton comes under hybrid type. And right, there are different kinds of parallel mechanisms and serial mechanisms are developed, and there are many mechanism comes under complaint mechanism also, complaint flexible. Okay, and that little bit of information, a little bit we will discuss a little bit later. Right, and there are various configurations, even stacking one over the other. Right, and right, you could see that it is hyper redundant. Many more degree of freedoms are okay, so available, or more than 6 are available. Right, and total, okay, you could say there is there are these mechanisms having by 15 okay degree of freedom. And if you talk about the fundamentals, right, and if you talk about any robotic devices or a robot, right, basically what is the explanation of, what is the definition of mechanism? Robot word, right, extension of mechanism, or you can say that machine. What is the definition of a mechanism? One of you can please come out with the definition of the mechanism. Mechanism, yes. Mechanism, any
Sir,
definition?
it is a kinematic chain which one link is fixed and it has a defined motion.
Okay, so a little bit more information. It is in basically an assemblage of links and joints, right? You are assembling various links of links and joints, and to form a kinematic chain, and one link fixed. For example, right, I mean, one, this ball and socket joint, right? It is attached with a structure. So basically, one link fixed, right? And then designed for the transferring motion, force, right, moment, torque, etc. Okay, so that is a basic definition of the mechanism. It comprises various links and joints. And the links, okay, unary link, binary link, ternary link, quaternary link, and multiple links, etc., right? Flexible links, etc. So another kind of right information. And the joints, okay, and you can say that it is a revolute joint, prismatic joint, cylindrical joint, helical joint, and the spherical joints and plane joints. And these are the 6 basic okay joints, and they're called as the lower pair. The first 6, right? They are the lower pair, and then higher pair, cam pair, and the gear pair. They are called as higher pair mechanisms. For example, take a revolute joint; it's 1 degree of freedom. Prismatic joint also 1 degree of freedom, and cylindrical joint. Cylindrical joint is having 2 degree of freedom. You can rotate as well as translate. And the helical joint, for example, the bolt and nut. Here, see, 2 arrows are mentioned, but how many degree of freedoms are okay available for the helical joint? And here, helical joint is 1 degree of freedom, but here 2 arrows are mentioned. How? Say cylindrical joint, 2 arrows are mentioned. Okay, it is having 2 degree of freedom, but a helical joint, okay, here, say cylindrical joint, 2 degree of freedom is mentioned, but a helical joint, there are 2 arrows, right? One is for rotation as well as for the linear motion, but it is mentioned as 1 degree of freedom. How? Any idea? Any idea? Okay, here the definition of a degree of freedom is number of independent parameters required to define the motion. Number of independent parameters required to define the motion. I repeat again, number of independent parameters required to define the motion. See here now, and if you rotate the nut, okay, nut can, okay, you are rotating the nut, also rotary motion, and also at the same time, nut can translate. But this rotary motion and the translation can be combined in terms of pitch. In terms of pitch. So one motion is depending on the other. So they two are not independent. So one motion is dependent. So finally it is 1 degree of freedom. So by this way only, so the 1 degree of freedom is available only for the helical joint. Okay. Then spherical joint, I know that it is a gear lever. You can, so 3 degree of freedom, 3 rotations are possible. And the plane pair, I know. Plane pair, right? 2 linear motions and 1 rotary motion with reference to the third axis. Right? So like this. And the gear pair, cam pair, and the 2 degree of freedoms are possible because you can rotate as well as a little bit of translation also possible. For example, you can rotation as well as up and down. Okay. So right. So this is the 2 degree of freedom information available for the gear pair and cam pair. And right, the basics of the joints are basically they are 6 joint. Yes, yes, I think somebody raised. Yes, sir. Okay, so now we will move on to this degree of freedom. When you talk about, we are not going very deep as far as a degree of freedom analysis, etc. But it's for an example, right? When you talk about the degree of freedom, that the people should know what is it. So it is the Grobler criteria. There are different criterions available for finding the degree of freedom. Grobler criterion, Kachapa criterion, Dubrovsky formula, family concept. Okay, there are other varieties are there. And this is one important criterion. From using this criterion, you can easily find out the degree of freedom of the mechanism as a whole. So when you talk about the degree of freedom of joint, that is different. Okay, all these put together, all these joints, degree of freedom, the joints are put together. Okay, how to calculate the degree of freedom of the mechanism as a whole. Okay, so that is obtained based on the Grobler criterion, Kachpa criterion, Dobrovsky formula, and degree of freedom concept. Okay, so now this equation, the lambda is a degree of freedom of space in which the mechanism is intended to function. If you want to make a planar mechanism, lambda is 3. If you want to make a spatial mechanism, lambda is 6. Okay, 3 or 6 depends upon the kind of mechanism we got to fix, right? And so lambda is equal to 3 or 6, and n is the number of links. N is the number of links. And for example, this fiber mechanism, right? And this is a base link 1, and 2 link 2, and 3, 4, and 5. Okay, so how many? It is a fiber mechanism, 5 links. The joints and J1, J2, J3, J4, and J5, 5 joints. Okay, 5 joints. N is lambda is equal to 3, n is equal to 5, and j is equal to 5. And okay, then you will calculate f is equal to 2. What is fi? Degree of freedom of the individual joints. Degree of fi is equal to individual joints. Okay, here how many? 5 joints. So f1, f2, f3, f4, f5. Each joint is having one degree of freedom, right? Revolute. So so this second term is you will get 5. Okay, and correct. So that is j is equal to 5. Then by this way you can calculate the capital F is equal to 2. Similarly, is a pantograph mechanism. Pantograph mechanism, you will calculate F is equal to 2. And this is a straight platform mechanism. And right, and here, right, how we are getting, and there is one more concept, right? And I think that will not better not to discuss because we have to go in deep. And there is a passive degree of freedom is concept, because that if you put the top and bottom spherical degree of freedom, right, the mechanism become uncontrollable. So practically speaking, in a general right design category, the bottom is replaced by universal joint. What is universal joint? I think this universal joint is not there. One more joint is called a universal joint. You could see the one joint before the differential of a truck, bus and trucks, right? You have the rear wheel, middle, you will get a box.
So you are not audible here, sir.
Sir, you are not audible.
Nobody is audible? I think some loose contact. Hello? Hello?
Yes, now you are audible, sir.
Oh, okay. Please alert me, in case of any issue. Please alert me, and right. And any how long it was?
Just few seconds.
Yes. They're not audible. Okay, now it is fine, right? Okay, fine. Yes. And right. Now, when you talk about, when you start designing things nowadays, okay, all the students are using it. There are so many freeware softwares available, right? There is a linkage, and there are so many softwares, and we are also using the free softwares are available in the designer mechanism. You can simulate the motion. You can see that, okay, all the 6 degree of freedoms are available, or how many degree of freedoms are possible, which degree of freedom is not available, how to redesign it, can I redesign? Everything is possible nowadays using the simulation softwares available. Okay, and every institute, for example, Professor Saga developed right a software that also many people started using it. Okay, so Saga of IIT Delhi, right? And so there are many free softwares are available who can and one can easily explore. Okay, so of utilizing it to the maximum possible extent. And yeah, so these are all, I think one can easily see it. And it is, I don't go to, okay, it is video is not available. Okay, move on to this. And if you talk about the right humanoid robots, the design is very complex. And you don't see that, okay, people are showing that very humanoid robot, but its design is very complex and imitating the motion. And there are a number of motors, okay, and the single hand itself, it is very difficult to imitate, and mathematical modeling is very important. And so right, so this slide is only to throw some light. Okay, so right, the what extent the mathematical modeling is very complicated with many degree of freedom. And now, and there is another domain that, and when you miniaturize, right, a robotic device and a smaller version, the classical links and joints will not come into picture. If you were to replace those classical links and joints with a compliant devices, and when you talk about the compliant devices, there are compliant materials available, and such some materials are called as smart materials. Okay, and what extent you can use in these smart materials in robotics, that we will explore now. And what is smart material? What is the right? What is a smart sensor? What is a smart actuators? Okay, you can spend a little bit more time, and here you will not find much time because in exploring too much, I have another 30 more slides now. With this, the time is 1:44, and I try to close before around 2 o'clock, so that I will. Okay, so and right, there are smart sensor systems. They are capable of right adaptive self. They are having possessing self adaptability, self sensing capabilities, and they possess memory, and they have special decision making capabilities also. And another domain, smart structures. Okay, and many even robotic devices also incorporate such kind of sensor systems, such kind of smart structure systems, etc. And if a structure is capable of acting like a sensor, actuator, and along with a controller, then we can call as a smart structure. And there are MEMS devices, smart MEMS devices, and many people are developing right a compliant smart MEMS. Okay, and right very micro scale objects, etc. And the notable materials and the smart materials can be that could be used in the robotic area. Basically, two materials. There are of course there devices, but the notable devices are two. They are shape and alloys, electroactive polymer actuators. And the shape and alloy, their function is if you heat it. Basically, there are other aspects also without heating also possible. But overall, if you heat it, the length will get reduced, and the dimension will get reduced. Because it will shrink if you heat it, and if you remove the heat, it will expand. Okay, increase the length or volume increase. Okay, that is the basic information for shape memory alloy. And they shape memory alloy. For example, what extent it was right? For example, initially it might be a dimension is 100 mm, right? And now we are beating heating, it is going back to 90 mm. Once the heat is removed, it will come back to 100 mm. So that is the reason we are telling that it is a shape memory alloy. And electroactive polymer actually is basically function like a cloth. And so it is there is a polymer layer in between, and top and bottom sandwich like a electrodes. If these electrodes are connected with the power, okay, they work like a capacitor. Okay, and there is a capacitor. What will happen? There is a development of Maxwell forces between this top electrode and bottom. They try to attract. So this due to this attractive force, the middle layer is soft polymer. So polymer layer will skews. So this way, the x direction, y direction, there the size will get increased because thickness is getting reduced. So this motion can be explored further in the development of robotic the actuators. So they are called as a electroactive polymer, okay, actuators. And there are other devices also like piezoelectric materials, electrostrictive, magnetostrictive materials. They change in their shape when they are subjected to magnetic field. They similarly electro-rheological, magneto-rheological fluids and solids. What is the rheological properties? Density, density and viscosity. Density and viscosity are the two basic rheological properties of the fluids and solids, okay, semi-solids like grease, etc. And right, where such kind of smart materials subjected to electric field or magnetic field, okay, their density and viscosity will change. Okay, they are called as electrorheological and magnetorheological fluids and solids. And there are various other sensors and devices, thermochromic, photochromic material, right? They respond to their temperature or they change in color. Okay, and pH sensitive polymers. And I think then there are scientific devices, right? And when we test our right and glucose level or the pregnancy checking, and all this technology is being utilized. And the holochromic material, then photomechanical material, self-healing material. What is a self-healing material? So if you paint this, suppose if the structure is erected very tall, and it is very difficult to go to the top, and the top is subject to wind loads, there is a possibility that there can be a formation of a crack. Okay, and if this paint or paint like device is supplied, and if there is a crack, that the paint, the material, self healing material, they penetrate inside the crack. Okay, and make the structure intact. Okay, they are called as self healing materials. So, okay, there are many smart car, many car manufacturers are okay, incorporating. You can easily explore further. And there are various hydrogels, right? And aged persons, there is a kind of hydrogels because the lubrication property will get diminished during aging. So these kind of gels are being right injected. Okay, so between our in the knee joints especially. Okay, those things are medical grade gels are there. Okay, that is another area. And there is various other medical areas, right? Biological where biologically available materials are being used, like our artificial fingers and tendon and surgery, various surgeries. Okay, there is materials being used even like nerve and like sensors and various sensors, and this area is very already grown up, and you can also even many new materials also it is coming up every day. Okay, so please you can, if anyone is interested, please explore further. And there are ferrofluids or color changing smart materials, the general other categories, right? And the ferrofluid, aerogels, metal forms, and nanotubes, carbon nanotubes. Okay, and this is another kind of development. So when you incorporate kind of smart material, smart system in the robotics, various factors need to be considered. How many number of links and joints you want to reduce or increase? Okay, what is the weight? Whether weight is maximum weight allowed. So sensing capabilities, two functions required or not. Okay, what extent it should be flexible, and capabilities like degree of freedom, etc. And right, yes, of control issues, then the cost, etc. So there are many factors one has to consider during the design phase. And I already said there are two materials are capable of giving more information, more that design, right? They facilitate design of micro devices, and their materials are shape material and the electroactive polymer actually. Each one is having some plus point as well as negative point. And right, and there are so many things are associated with the shape of mirror. Those things I'm not getting. I'm not discussing now. There are various smart materials. Like not only there is basically nickel titanium is a basic material, and for example, our orthogonal clips itself, yeah, a shape of material, or copper nickel, sorry, nickel titanium copper for increasing the flexibility of the wires and the clips, etc. Our orthogonal clips, they're adding copper. It is a smart material, okay, SMA material. Only there are very other materials also there, and there is a basic functionality to explain the SMA actuation principle, right? If you heat it, it will go back to the, it will reduce the dimension and it will increase. So it is an example way to explain the how an SMA actuation can happen. So if you take a 100 wire, you elongate it and apply a force and elongate it, and you remove the force, it will be there in 100 mm. If you heat it, it will go back to the 100 shape. So this is the information, and okay, there is other things are there, and various kinds of chip and relay wires, and various kinds of heating and cooling technologies that the people are using it, and various kinds of control strategies, and right, various kinds of feedback systems are available, and various applications, right? And yeah, micro grippers and fish-like devices, SM actuated grippers, yeah, robotic devices, and colonoscopic devices, and yeah, the compliant devices, and various applications in their cars. Okay, so all these things are being used, and yeah, various valves and devices, and then biomimetic sites. Okay, and yeah, modular type devices. For example, if you take a copy, if you want to copy the motion of a snake or right or earthworm, and you go to make the design the thing in modules, various modules, and each module need to be connected. There are mathematical issues, and those things will come, and right, and various medical areas, right? One can use various kinds of yeah. These are the devices There are robotic devices developed based on the smart materials, etc. And right, there are pedicle fixing, okay, that is being used in smart surgery, etc. And various electroactive polymer devices, right? And now this is, we are right. We have said the two materials are important. One is HFM alloy and the electroactive polymer actuator. These two are the suitable material in the development of robots and robotic devices. And right, if you talk about the polymer, right, electroactive polymer, there are ionic electroactive polymer actuator devices and electronic. There are two categories, and please explore further. So I already said the working principle of electroactive polymer actuator is like a capacitor. If the top and bottom electrodes are okay powered on, then it will shrink. Okay, then that property is explored in the development of actuators. Okay, there are devices like capsules, EP capsules, and there are right devices developed based on the artificial hands. Okay, developed based on this EAP technology, etc. Okay, so there are compliant devices. Then this introduction also I have to give compliant robotic devices. Even a Rambla itself, it is a compliant device, and there are kinds of compliant devices and grippers. I think developed by Professor Ananda Suresh of IIC Bangalore. And yeah, every institute I think people are developing a lot of things. This is taken from his website. Okay, so you can explore further, and sir is developing a lot of devices and working in compliant mechanism area. So these are the right surgical grippers, right? Grippers normally used, and now people are right finding ways to convert it into compliant devices, so that when they such kind of mechanisms are used in the grippers, right, so for handling soft tissues like a kidney, heart, lungs, etc. This kind of compliant event, there is a possibility that the metal surgical tools may damage and the bleeding may happen. And so if you use replace those devices with a compliant device, right? So the safety of the surgery will get ensured. Okay, and right. So now is a part two, and probably we can have a break. Right? What is the time now? It is. I think we can have a break now. Now it is 1:54. Okay. So any queries for this up to this? Now it is 1:55. Okay, 5 minutes we can have a discussion interaction. Then yeah, two ten, right? It is a break. Then we can start at 2:10. Am I correct? The schedule is correct.
Yes, sir.
Okay. So please go ahead. And if there is any, right, we are entering part two, and I will ask, I will request. So yeah, so there is, I think this we can ask the students to continue, and then they will also get experience, and they will be more energetic than me, and right, you can also enjoy with their session, and they are new, and that one student is the Raj Kumar is right going to complete his PhD work, and right, and you will not give all the information related to his PhD work and all. Some oral information they will give, and right, if anyone want to know more and know further, you can very well contact me, and for okay for the dissemination of information. For that we are here now, and say why this kind of deep sea, right? The information it is available with one point, right? One point. Say right, need to be shared to all the people, so that you yourself again establish another center, then you will give, then you will pass the information various people, so it is like a chain reaction, right? It is an atomic chain reaction like that, so that with the minimum time, so information reach many people, and yeah, right, so that is the exchange of information, so that maybe within minimum time, right? And so the country will be self-sustained, and in terms of manufacturing, in terms of technology growth, in terms of any sustainable development, in terms of money, finance, etc. So that is a vision of our government, and for that we are working. Okay, so then we have to make our generation to work. So then only ultimately that our country will reach the goal, and the youngsters will receive their benefits of the current development and the future developments. Okay, so this is the one, and now we can so. The discussion now, the talk is open for discussion, and finally we will come back, but I don't know about how many what is the time, we will get the time or not, because right, and it is a packed session, and we thought of giving many more information, so that we will carry forward and feed to your juniors, right? Your juniors in that sense, your children as well as your students. So that is the reason calling us juniors. Okay, so with this, if anyone, yeah, so anyone want to have some kind of minimal level of interaction, please pass. the information, we can share it now, right? Or you can also shoot up email, and very initial slide I have given email. Okay, it is MSK, M Sree Kumar, MSK at IITDM.ac.in. You can also visit our website, and right, a lot of recruitments are, I think recently recruitments are happening, and a lot of procurement, everything is happening with the initiatives of our new director. And right, and so any information is required, please visit our websites frequently and please get the information. Okay, so so like this, and our faculties also conduct right, various kinds of right, workshops and faculty development programs in image processing and cloud computing, and many areas. People keep on conducting many yeah, the workshops, and I usually conduct in some basic, very basics. And this June, one basic fundamental of kinematics. Okay, so with the maybe with the other faculties in the area, so we try to organize, and mostly we include simulation and the practical aspects, and right, all these things will. So anyone who joins for our this one also, you will get the fundamentals, so that it will be used for teaching. And we will not cover various areas like this. We'll focus more on kinematics and trajectory analysis. Okay, basics, even basics and advanced level. So this June basic levels will come, and this December advanced level will come. If anyone is interested, you can check and apply online. So, okay, so now any other query or clarification? I think, I don't know whether you had lunch or not. I think probably, so the schedule says that before 1 o'clock you might be having lunch, and okay. So now anything available for short right interaction? Any question? Finally, there is a question and answer session. I think we will ask the people to have. Okay, so at the end of the 2 hours, and we'll give some 10 questions online, and we'll be asking you to fill it. Okay, please try to do it, and right, carry a lot of information from this workshop, so that your next generation, you will feed to your next generation. Okay, please attend all the sessions very seriously. I think today is the last date, it seems. So you might have attended all the sessions very seriously. Even in the future also, if you want to attend the session, please attend all the sessions very seriously. You don't miss anything. So with this, I think if there is no query, maybe you can ask later also. Maybe, right? And please continue. Maybe after this 10 minutes break, please come back and continue. And so our scholars, I think my scholars will continue with the other recent developments and what they are doing it. Okay, so they will throw some light, and so that we can capture and continue further. Okay, see you all.
So thank you very much for this wonderful session, sir. The various concepts you have discussed in this session, like robotics, the type of robotics, the industrial robots, different type of mechanism, different concepts related to that, degree of freedom, smart materials. So that was really an informative session, and definitely it will help to all the participants in that particular field to explore it. So thank you very much, sir.
Yeah.
We have break for 10 minutes. After 10 minutes, we will meet again for the next session, sir.
Okay, yeah, thank you so much. Please, we'll meet again. Okay, at the end of the session, try to meet again. Okay, thank you so much. Please join after 10 minutes.
Sure, sir.
Yeah,
Yes.
see you.